Hi. So I'm doing this video to help you simplify radicals, especially the square root in this video. And square roots with variables. So let's see. We have this problem. And they say simplify this radical expression as much as possible. Well, something important to know is that for every x squared, we're going to pull out one x from the square root. So every time that we have x squared underneath the square root, the square root of x squared is just x. So I have to pull, what I end up doing is I end up pulling an x squared out to the front and it becomes an x. So it's no longer under the square and it becomes an x on the outside. So I have to pull out for every x squared or variable squared or prime number squared under the square root, I pull only one x out. So I basically have to half that number, right? So if it helps you, you could think about, well, how many x squareds are in x to the 16th? Well, there's 8 x squareds in x to 16th, right? Because if you want to think about it, you can expand it if you wanted to. Actually, I'm going to expand everything so it's a little clearer for you. By the way, 8 is actually the expression 2 to the third, right? Because if I prime factor 8, it's 4 times 2, which is 2 times 2. So it's best everything under the square root, you should write it as its primes to the exponents that they are. So 8 is actually 2 to the third, and then x to the 16th, y to the 15th. So let me just simplify this first one for you. Okay, so x to the 16th, that's actually it's actually x squared times x squared times x squared times x squared times x squared. 1, 2, 3, 4, 5, 6, 7, 8 times, right? Because what would happen is I would add all those exponents when I'm multiplying an exponential expression like that. I add with the same base, I add all the exponents. So 2 plus 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 2. If I add 2 8 times, I'm going to get 16, right? So for every one of those x squareds, this is going to become a 1x on the outside. And then this one's become a 1x on the outside. And this one's going to become 1x on the outside. And that one's become 1x on the outside. And so you can see that really to figure out how many x's belong on the outside, I just have to figure out how many x squareds are in x to the 16th. And I really just ask how many 2's are in 16. And so if I take one x, add it to the front and multiply to the front, that would give me 1, 2, 3, 4, 5, 6, 7, 8 x's. So this becomes 8 x to the 8th on the outside. I have 1, oh, and I forgot the y to the 15th. But I have 1 2 squared, so I can bring out that, and a 2 also goes to the front, and 1 2 is left under there because I can't take the square root. I can't take the square root and get a whole number when I just leave 2. So then I didn't write y to the 15th, but it would be y squared times y squared times, I break it into how many y squareds fit into to fit y to the 15th. And I just quickly do 15 divided by 2. And that's going to be 7 with 1 left over, right? So that 1 left over I'm going to have 1y to the first power, right? And so if you went 2, you can double check this. If I add 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2 7 times, that's 14, and plus one more time, that would be 15. So I do actually have this expression underneath here. And what I did is I create, every time I have a pair of y's under the square root, I made it into y squared, right? And so for each one of those y's, I'm able to take a y out to the front. Out from under the square root, because the square root of y squared is y. And that one y just has to stay under there. So we end up getting 1, 2 is left. We get y to the 7th, 2, and just y. So x to the 8th, y to the 7th, square root of 2y. That's what this whole thing simplifies to be. So I kind of always have to remind myself of this process, to remind myself how to do this problem correctly. Once I do like one problem like this, then I kind of get the hang of it. And I'm like, okay, I just have to look at how many 2's go into the exponent. And that's how many come out. My remainder is the amount that stays under the exponent. So we can do these a lot quickly now that we kind of understand the rule behind it. Okay, so let's use the shortcut rule. The shortcut rule would be write everything in exponential form. Prime factor that 8. So 2 to the 3rd, x to the 16th, y to the 15th. And now I divide everything by, all the exponents get divided by 2. So 3 divided by 2 is 1. And remainder 1. So I have 1, the number here is the number of 2's coming out, and the number down here is the number of 2's staying underneath the hood. So 1, 2 coming out, 1, 2 staying under the hood. Okay, then I take 16 divided by 2, I have 8, remainder 0. So that tells me that I have 8 x's on the outside of the hood, and I have 0 x's left under the hood. So it becomes, I'll just write it on the outside of this, 8 to the x. And then now I just need to figure out how many y squareds are in y to the 15th. So I just do 15 divided by 2, and that's 2 goes into 7 times 14, remainder 1. So this is the number of y's on the outside, so times y to the 7th. This is the number of y's on the inside, y to the 1st. And that's what this first one does. Okay, let's do the first same thing with this second one. So I have, and this is negative, so we can 2, let's just put this, oh, and this little 4 is telling us that this is actually a 4th root, not a square root. So I mentioned with this first problem, there's really an indivisible 2 here. Whenever the default for this radical symbol is 2. So if there is no number on the outside here, it is meant to be, you can't assume that it's a 2, but because there's a number here on the outside, now it's a 4. And so just like we took all the exponents and divided by 2, now we're going to take all the exponents and divide by 4, because with this particular square root, every time I have x to the 4th on the inside, then 1x is going to come out to the front for every x to the 4th that I have under. So I'm going to rewrite it, x to the 32, I'm gonna divide 32 divided by 4. That's 8 times, and the remainder is 0. So I think you just kind of write the negative sign, but it's not going to affect any of our calculations as far as like what we're going to do is simplifying the square root right here. So we'll just keep it there. But I have a 2 under the square root. that I cannot write it as like any fourth power, so I can't bring this 2 out. It's gonna have to stay under the root. And then so x to the 32nd became x to the 8th, and there's no x's left on the inside because this remainder here is 0. This is the number of x's on the outside. This is the number of x's that remain underneath the hood. So then I take 29 and I divide 29 by 4. 29 goes into 4 7 times. So this is the number of y's that are going to come out. So y to the 7th. And it's going to be 1 y. This is the number of y's that stay underneath. So wow, we're seeing that actually we have the same radical here, which is very interesting. Okay, and then now for the last part, we have 4xy. That's not going to change, but we're just going to change what's under here. And it is a square root because it does not have any other number on the outside of that root, of this radical symbol. So it is a square root. So I'm gonna divide by 2, right? Each exponent by 2. 2 goes into 14 7 times and multiply. And so I know that x is, so this is the number of x's coming out of the square root. That's the number of x's staying under the square root. So we bring out this x to the 7th and we leave just the 2, but you're just leaving under there. And then y to the 13th, 13 divided by 2 is 6, remainder 1. So this is the number of x's or y's that come out to the front. And then 6, and then I'm left with 1. The remainder here is the number of y's that are left under the square root, which is 1. So I'm going to now clean up this multiplication on the outside here, because I have x the first times x the 7th, which will be x the 8th. So I'll have y 7 x to the 8th times 2 times 2y, square root of 2y, and then 2 times x to the 8th minus 2 times x to the 8th, y to the 7th times the square root of 2y plus, and now I'm just going to combine some of these all on the outside of the square root. So x to the 8th, 4x to the 8th, y to the 7th times 2y. And now we can see that we treat this root of 2y like any, like a like term. So like if I have like 7x plus minus 2x plus 4x, then I can combine all those like terms. I'm looking at this root 2y, I'm thinking that's a like term. I have this many, whatever, I know it's a weird like variable, but if I plug in something for x and y, I'm gonna get a number, and it'll say I have this many of the 2y's minus this many of the 2y's minus this many plus this many of the 2y's. So we can kind of, if you want to think about it, where we are factoring out the 2y from all of these problems. Typically when we have expression variables, we put it at the end. So then just all this other stuff that's not the 2y, I just pull out to the front. So it's y to the 7th, x to the 8th times 2. Okay, so that's 2x to the 8th, y to the 7th minus 2x to the 8th, y to the 7th. Okay, so that's exactly the same expression, but I switched the x and y, but they could be switched because multiplication is associated, multiplication is commutative. So then I add plus 4x y to the 7th. So that's all in the front, and I have all that times by 2y. Why did that y look like a 7 here? And see, these are going to cancel because, well, And so this is a crucial step here. If I took the 2y out and I put everything else in parentheses. So it's the equivalent if I have like 10x minus 5, I can factor out a greatest common factor, and it's 5. And I can rewrite this as 5 times 2x minus 1, because this will multiply out to be that, right? 5 times 2x is 10x, and 5 times -1 is -5. So a lot of times in algebra, everybody's really clear and okay with going from here to here. They're okay with distributing, but they forget that we can do the opposite of distributing, which is factoring out, right? So that's what we did with this. We took the square root of 2y out, and we're left with, in parentheses, everything else. So we're left with, in parentheses, 2x minus 1. So I hope that makes sense. So these are the same. So it's going to be 2x to the 8th, y to the 7th. That's why it's good if you're writing algebra. Usually you do it in alphabetical order, x and then y. I wasn't careful earlier, so it looks like these are two completely different terms, but they're really not, because you could just switch the x and y on them. They're the same. Now you can see they're the same. So it's positive 2x to the 8th, y to the 7th, minus 2 at that exact same expression. So these just cancel, and I'm just left with this 4x to the 8th, y to the 7th in parentheses. And then, so it's just, my final answer is just 4x to the 8th, y to the 7th times square root of 2y. And there we go. I really hope that you guys found this really valuable and really helpful. And make sure when you're inputting everything in the calculator that it knows both the 2 and y are under the square root symbol. That could be a mistake, that just entering your answer wrong mistake that you can make here. All right, have a great day. Bye.